Alright, so in this video I want to show you one more thing with half angle identities. We're still going to be using the same three formulas we used before. The difference now is they are now giving us the angle that we cut in half. And one of the indicators that this, like 67.5 or in this case 292.5 for the tangent, one of the indicators that we're dealing with a half angle is, think about this, what would it be like if you took a whole number and cut it in half? Like, let's suppose I had 11. If I take half of 11, I would get 5.5. So whenever you see a 0.5, that's a sign that you must have taken half of something. Obviously, you don't have to. Like if I took half of 10, that's still going to be a whole number. That's 5. But if I have a 0.5, then that means definitely I must have taken a half angle. So we have to do the same thing. We have to find the exact value. And for this first one, we're going to use the cosine formula. Notice that this right here is theta over 2. Theta over 2, the angle that we cut in half was 67.5. So in that case, let's find out the angle that we originally started with. So we can find theta by multiplying by 2. Multiply this by 2. That means theta is 2 times 67.5, and that's 135. So that angle is in the second quadrant. 2q means second quadrant. And theta over 2 is what we're given. That's 67.5 degrees. That's in the first quadrant. Why do we care what quadrant we're in? Because we're going to have to decide if it's plus or minus, and then this one is going to have to tell us too whether cosine will be positive or negative. So our strategy is very similar to the last. We pick the right identity, and obviously that's not hard to decide here. We have a cosine, so it's going to be this middle one. Double the given angle, we did that, and plug it in for theta. So here's what that means. We're going to, first of all, plus or minus is based on what theta over 2 is, or where theta over 2 is. It's in the first quadrant. And in the first quadrant, everything is positive. So we're going to take the plus right there. You don't even actually need to write plus, but we'll do it just for the sake of completeness. And then we have 1 plus, and this is what often confuses people. This right here, cosine of theta, what you need to put there, don't put 135 because that's not the cosine of theta. Cosine of theta is the cosine of 135. So you actually have to just take cosine of theta and replace the theta with that angle that you just found. And again, we found that angle by doubling 67.5. So all we're doing is taking this formula up here and plugging in the theta that we found. How did we find the theta? We found it by doubling this angle, because this is half of an angle. So we need to find out what was the original. Alright, so now we'll just keep going here. We have 1 plus, and then cos 135, this table that we keep seeing this show up over and over, and that's why I always encourage people to memorize it. This table has every angle that we're going to need to find exact values. So 30, 45, and 60, all of these angles are going to have something as a reference. And remember, the sines count up, 1 over 2, root 2 over 2, root 3 over 2. Cosines count backwards, root 3 over 2, root 2 over 2, root 1 over 2. So what we need to do is we need to find the reference angle for 135, and I'll draw that right here on the, let me move down so we have some more space. And the reference angle is going to be one of these three. In fact, I'll just type out these steps right here for finding exact values. You need to find the reference angle, okay, which we're about to do. Use the 30, 45, 50, 30, 45, 60 table. These are our 3 steps. And number 3 is use ASTC to find if it's positive or negative. So these are the 3 steps that we'll end up using on these problems. Okay, so here's what we need to do. Whoops, didn't mean to move that. You can see these problems get kind of messy. There's a lot of writing here, but okay. So what's the reference angle for 135? Well, we could just draw a circle here. Here's our unit circle. Okay, so there's 90. 135 would put us right here in the second quadrant, and the reference angle is going to be this one right here in green, and that's 45 degrees because that's what takes us to 180. Reference angles, whatever takes you to the closest x-axis. Alright, so we're really being asked to find the cosine of 45 degrees because that's identical with the cosine of 135 except for one thing. And maybe you can tell me what that one thing is based on what I just wrote. The one difference is we are in quadrant 2. 135 is in the second quadrant, and we said that right up here. And so that means this is going to be cosine of 45 except negative. That's the one primary difference there. So cosine of 45 except the negative of that. Let me just move that over there for now. Okay, so now we can finish this. We have 1 plus, and the cosine of 45 is this, but it's negative that, so minus root 2 over 2 over 2. And now we just need to simplify this. So 1 is the same as 2 over 2, and then I'll change plus negative into minus, and that whole thing is over 2. Let me make a, oops, sorry, I didn't mean to change the page there. Let me make a larger, oops, wrong page there. A larger fraction bar, or a different colored fraction bar, so you can see what we're dealing with here. So here's this red fraction bar, and then we can keep going. So we have a common denominator of 2, so we can now combine that into 2 minus 2 over 2. And then this big blue fraction bar is right there, and then we have a 2 still on the bottom. Okay, so now dividing by that fraction is like multiplying by the reciprocal. So this fraction right here is still there, and we're going to multiply it by the reciprocal of 2, which is 1 over 2. Okay, now how can we simplify that just a little bit more? And here's how we can do that. So we're going to have the square root of basically 2 minus root 2 times 1 is just 2 minus root 2, and then over 2 times 2, which is 4. And now we can take the square root of 2 minus root 2, and at the bottom, the square root of that is just equal to 2. So if you put that in a calculator, which is exactly like you see it, and that's a little bit hard to do with all those parentheses you have to put, but if you put that in a calculator, you can check it by also putting in this into the calculator, and you should get the same number. Cos 67.5 should be equal to this whole square root thing that we had at the bottom. That's the easy. These problems are easy to check that we got them right. All right, let's finish with the tangent example, and again, I encourage you to pause and give this a try if you haven't already, because ultimately that's the best way to learn these things, is to try them. So let me move some things around here so we can have these visible to us. Okay, and now we need to find tangent of this right here, and this is a half angle. So I want to find the regular angle. So if theta over 2 is equal to this, then I can find out what regular theta is if I double it. Okay, so that times 2 means that theta is 585 degrees. Okay, 585, if we draw our angle right here, 585, that's 360. Let me use a different color. Then we go, each one is 90. So 360 plus 90, that's 450. Another 90 would be 540. So that's going to put us right here. That's 585 degrees. Since this is 540, that means this reference angle right here, what takes us back to 540, would be 45 degrees. And that makes sense because it's supposed to be one of those 3 angles that we talked about. So this is basically, let me just indicate that this is 45 degrees. It's the same thing as 45, and that puts us in 45 degrees, but it puts us in the 3rd quadrant. So that's what we want to indicate. The reference angle is 45 in the 3rd quadrant. This angle, which is theta over 2 is this, and 292 puts us in the 4th quadrant. So we're going to keep that stuff in mind as we use this formula right here. So let's do that. So tangent of 292.5, that's what theta over 2 is. Okay, tangent of 292.5 is going to equal this formula that they give us right here, which is this. It's plus or minus, and actually let's decide right now what it is. We're at 292.5. That's theta over 2. That's the 4th quadrant. In the 4th quadrant, what is tangent? Tangent in this quadrant is negative. Okay, so we're going to pick the negative of that, and then we have 1 minus, and then 1 plus cosine of theta. And we found out what theta is. Theta is 585, or we could use the reference angle of 45, and that will be easier for us. Theta is 45, but remember, since theta is 585, it has a reference of 45. Since theta is 585, that puts us in this quadrant right here. Because we drew out the angle on this circle. We want 585 put us in the 3rd quadrant. What is cosine in the 3rd quadrant? And the answer is cosine is negative. So this is going to be negative, and so will that. So up on the top we have minus a negative, which is like a positive, and the bottom we have plus a negative, which is like minus. So let's just clean this up a little bit. So we have a negative square root of 1 plus cosine of 45 is root 2 over 2, and then on the bottom 1 minus root 2 over 2. And we can keep simplifying this. So this is the same thing as 2 over 2, and it's the same thing as 2 over 2 down there. So we're going to have this, let me make a big fraction bar so you can see it. So this fraction bar is right here. The top is going to, when we combine these, we're going to have 2 plus root 2 over 2. And the bottom is going to be 2 minus root 2 over 2. If you multiply by the reciprocal of the bottom, these 2's will end up canceling each other out. So we're left with the following. And the hard part of this problem sometimes is, I mean, we pretty much have the answer. The hard part is just cleaning up all the fractions that we get. We have 2 plus root 2 over 2 minus root 2. That's not wrong, but it would be nice for us to not have those roots in the bottom. So we can do that if we multiply by the conjugate. And the conjugate of 2 minus root 2 on the bottom is 2 plus root 2. So now let's FOIL this out. And actually I think we might have dropped a negative. I dropped a negative somewhere, right? We had a negative here, so it's still here, which means it's still here. Let's not forget that. So we're going to have this. We have negative, and then let's FOIL out the bottom. So the bottom is going to be 2 times 2 is 4. We have 2 times positive root 2, and then 2 times negative root 2. Those are going to cancel each other out. And then negative root 2 times root 2 is just negative 2. So that whole bottom nicely simplifies out to be, let's not forget the negative, that whole bottom just simplifies out to be positive 2. And that makes things easier for us. Okay, that's what our goal was. Our goal was to get rid of the roots in the bottom. And then the top, when we FOIL the top, we're going to have 2 times 2 is 4. And then we have 2 times plus root 2, and then 2 times another plus root 2. That would be 4 root 2. And then finally we have root 2 times root 2, which is just 2. So let's simplify this just a little bit more. 4 plus 2 would be, actually that would be 6. So let's just simplify that. So we can say this 4 plus that 2 is 6, plus 4 root 2 over 2. Very last thing we can do here is all of those things are divisible by 2. So 2 goes into itself once, it goes into that 3 times, it goes into that 2 times. So our final answer is just 3 plus 2 root 2 over 1, but we don't need to write the over 1 because anything over 1 is itself. And that's how we use the half angle formula.